Check the mic and make sure it's
So welcome everyone to the group chat brought to you by Overmark. I'm Darrell and I'm here today together with Xin Wei. Xin Wei, how have you been?
Tired, but doing well.
As you can see, we're both pretty tired. If you're watching this on YouTube, you'll see that we put a little filter just to cheer ourselves up, okay? But it's because we had a long day with lessons and stuff. Anyway, today's topic will be relevant to a lot of students, a little bit more catered towards the O-level side. The topic today is how to improve quickly for chemistry. And this is one of those topics that I've been waiting to do because I know there's a lot of students struggling with chemistry. Often hear that out of the three sciences, people hate chem the most, all right, and think that is the most difficult. But I think today's podcast would hopefully shed some light to help you guys along your journey for chem. It's actually not that difficult, but we can talk more about it. Xin Wei, for you in school, was chem a struggle or was it okay?
I'm generally stronger in my sciences, so I did quite well for my chem bio in general. Yeah, so it wasn't that of much of a struggle, but I know that a lot of people struggle with chem in both O-level and A-level. Yeah.
I think for myself, chem was also rather difficult when I was studying it. Okay, I mean, surprisingly, I became a chem tutor, but I think one of the main reasons why I wanted to teach chem was I was deciding what subjects to teach. Actually, I'm naturally more inclined to math and physics. Like those have always been traditionally my strongest subject. But when I teach chem, I realized that there's actually so much value I can bring because it is one of those topics that if you just study it without proper guidance, it's really very difficult to do well. And I'll talk more about that later on. And I see that a lot of students, after I guide them through the proper thought processes and stuff, they realize that actually chem is not as intimidating as it seems. So back in school, when I was doing for my own chemistry, I didn't do that well actually. But I think what's more important now is that when I taught a lot of my students, they could easily get A1. And I saw what the difference was from my own experience and what has happened after I guided them through. So today, throughout the podcast, I'm going to attempt to shed some light on that. And hopefully you guys will have an easier time, with your own exams and stuff. Okay, anyway, let's jump straight in. So my very first tip is understanding concepts. Now, I know understanding concept is very vague because it could mean a lot of things. Like, what do you mean by understanding concepts? Now, the first thing you need to avoid is definitely memorizing. So if you think that chemistry is a topic that you can just memorize and do well, you need to get that notion out of your head. Because if you stick to memorizing, a lot of the things will not make sense and you'll start getting confused very quickly. So the first thing I wanted to put out there first is don't try to memorize chem. It could work to a very small extent. But if you're aiming for anything that is close to a B3 and above, memorizing chemistry will not work. Now, when we are talking about understanding concepts, there are various ways you can do it. One of my favorite methods is to use analogies to help students understand maybe a more difficult concept to understand, but then putting it in simpler terms. So one of the most difficult topics in chemistry is electrolysis, right? Everybody struggles with electrolysis. So rather than talking about the anode and the cathode, one of the most common analogies I always tell my students is to think of it. I'm going to go into a bit more specifics here.
Yeah,
which is
sure. I think students will appreciate that.
Right, which is to think of it more as a shop and customers. So if you are connected to the positive terminal of the battery, you are a positively charged electrode. So you think about as a positively charged electrode, what kind of customers you'll be attracting. Will you attract the plus or the minus? You will attract your negatively charged ions, which are called anions. So if you attract anions, what should your shop name be? Your shop name should be called the anode, for example. Then you can go further to talk about, hey, what's your customer trying to do at the shop? They're trying to get oxidized, something like that. So it builds up eventually. But if you merely try to memorize that, anode is positively charged, and then later on you go on to electric cell, it's going to get very, very confusing. So I think it's very important for you to get proper guidance, and knowing these analogies go a very long way because it really helps you understand it on a very deep level. So whenever I teach my students, I try not to talk too much about the concept itself because half the time it doesn't make sense. But I try to bring across analogies or certain scenarios that they can easily visualize and remember. Another example is endothermic reactions, right? Bond breaking is endothermic. Now, how do you know that, right, without memorizing it? For me, I get them to visualize I always show them an image, right? You go to the mama shop, you buy a popsicle, you know those frozen popsicle, right? Then I told them, how do you break it and eat it? So normally what I did when I was a kid in primary school, right, was that I'll take the ice popsicle, all right, in two hands, I'll smash it on my knee and break it. Then I can like enjoy the popsicle and share with my friend after. Okay. But what is the whole purpose of showing that whole visual? Is because I want them to remember, if you want to break a bond, you want to break the ice popsicle, or you want to break a tree branch, you need to garner energy, then you break it. So you need to absorb energy so that you have enough energy to break a bond. That's why bond breaking is endothermic and it absorbs energy. So those are just one of the many analogies that I like to tell, because it's a lot easier to remember a story, to remember a set of movements rather than to memorize facts. So those are one of the main things on how do we make chemistry easier. Bring in appropriate analogies. Now, if you're self-studying and you don't have a tutor to guide you, that's perfectly fine. You can look at a concept and come up with your own idea, find an interesting way to think about, what situation can apply to this context. For example, another one, sorry, I'm just throwing out a lot because this is chem. No, we say bond forming is exothermic. So how I get my students to remember is simple. Bond forming is like the two celebrities that you're shipping, they finally get together, right? So they hold hand, finally. And at that moment, it's a celebration. So you release like fireworks, right? So releasing fireworks is hot, right? It's exothermic. So bond forming is exothermic. So those are just some situations that I came up with. I hope you can find your own. And once you study and you understand this analogy, you realize that, hey, chemistry is not as intimidating as it seems. So Xin Wei, for you, does it work when you were a student for chem?
I love hearing like all these analogies by Darrell because it is very different from how I study. So, but it's really fun to listen to all these analogy. But me as a student, I didn't really study like that. Like, I definitely agree with like how understanding are very important and never ever try to memorize things, really. Like, I feel like even for humanities subject, right, you can't exactly purely memorize. I know like humanities subject, usually they say, I just memorize, really, like, but I feel like even for humanities, it's never the solution to just memorize. So I agree that understanding concept, but for me, it was like, I really would just understand it factually. Yeah, but it's really fun to always hear Darrell talk about his analogies. I think it helps because that definitely lasts, like, it's just like stronger impression than understanding facts. Yeah, but that was how I studied. Yeah. And
go ahead.
I feel like understanding concepts are very important because the questions can be easily tweaked, like especially chem. Like I think there is a lot more like solving problems in chem. And if you purely memorize, you see the question, as long as they tweak it a little bit, right, you can't solve the problems already, and you are not able to answer them. So I think the questions but are a lot more varied for chem, so you really cannot just memorize.
I think the main message I'm trying to send here is that in the exam is really not a test of regurgitation. It's not about like memorizing stuff and vomiting everything that you remember. But you see that exams, they are definitely trending towards more of like your thinking skills and problem solving. So knowing your content is like, if you're playing a game, for example, knowing your content means you enter the quest with the items that you need, right? Then later on, when you tackle the question, that's when you're like fighting the boss, right? You need to defeat them with the items that you already have. So, I mean, knowing your content is one, because without the items, you can't even take on the fight, okay? But then learning how to take on the fight, all right, requires a deeper level of understanding of the mechanics of the game. So when we say understanding, is not like you memorize the exact set of movements you're going to do, right? You kind of need to know how the game works, the flow of the game. And that is the same way you can be thinking when you're approaching your chemistry or even other sciences, if I put it that way. Now, I think I can talk about my second one. This one is more exam focused. It is about nailing your answering technique. Now, a lot of times while we might understand a certain concept, like those that we have discussed earlier, but if you're not able to put it in the exact words that is required in an answer, you will not get the mark. So I know answering technique sounds very technical, but it is technical because you need to know that for a specific set of answers, the sort of things you need to showcase in your answer is fixed. For example, right, if you want to talk about oxidation state, right, in chemistry, redox reaction, there's a specific way you need to phrase your answer. For example, the oxidation state has increased from 0 in Fe to +3 in Fe2O3. You cannot just go and say that, oh, oxidation state has increased from 0 to +3, right? Because you're not stating which compound that oxidation state belongs to. So it makes your whole answer incomplete. In fact, my answer, the one that I just mentioned, is not even that good because you're supposed to say oxidation state of Fe has increased from 0 in Fe to +3 in Fe2O3, something like that. So, I mean, it's getting very technical here, but the good news is that you don't really have to worry about this because as long as you have access to a 10-year series, one of the fastest way you can brush up on your answering technique is to not even do your TYS, is to go and look at the question and go and read the answer. So the first step is not so much, I mean, yes, learning content is important, but what I'm trying to say here is that if you're approaching an exam season, mid-year exam, prelims, end of years, you want to know how to be able to attempt the questions and score the mark. So you need to look at how the answer sheet phrases the answer, and then you're going to learn from that. So that is sort of the structure that you're working from. So a lot of chapters require very in-depth answering techniques. If you are missing out something here and there, you start losing marks and you realize that suddenly your score is not as desirable as it seems. So this, I think, is very applicable to bio as well. Answering technique is one of the most important things to master. And the quick fix for this is to look through many answer sheets in your TYS or your assessment books or whatever. If you have our curated notes, you'll find plenty of that, like the answering techniques already listed out for you. All you have to do is to go and look at it, understand how to approach the question, and so that is sort of like your strategy for winning in the exam.
Darrell, would you agree that no matter what kind of tricky question they ask, right? Like no matter what kind of application question they ask, right? The keywords to answer those questions are always the same.
That's why, right, I say the trick, right, is you go and look at the answer sheet because the answer sheet will state how exactly you get the mark. You realize that it's usually the keyword that's given the mark or the key phrases. So as a teacher, right, you ask me in Xin Wei, we don't read your entire sentence to give you the mark. We are spotting those specific keywords or specific areas, then we give the tick. That's how you get the mark. So I think that's something that on the game theory side, you can think about, like, how do you game the system, right? You know exactly what you need to do to get the reward, then sort of you want to cater your answers in that specific way. So Xin Wei, completely agree on that.
Yeah, so I always tell my students, no matter how hard the questions sound like super foreign, right? But the answer you definitely know one. It's just how you're going to phrase it. Because they cannot test you something that you totally don't know. That is not fair. So, but it's just how you link this question to what you already know. I think that is also part of like doing a lot of practices, doing a lot, like coming into contact with questions would help in that kind of like sensitivity and like detecting what kind of topic or how to answer those kind of questions. Yes.
Yeah, so I hope that this is clear, right? You know that at the end of the day, you're taking a test, an exam, a weighted assessment, questions will be phrased in a certain way. So go and master your answering technique. Okay, now down to my last tip. I think this is one of the most important one, which is connecting the dots. Now, for chem, this is especially true, right? For other subjects, I think it's true to a certain extent, but for chemistry, this is one of the most important ones because a lot of time when you study chem, you might have the impression these are separate topics, right? Topic 1, 2, 3, 4. You follow the school textbook, you go on and on. But what you don't realize is that many of these topics are actually interlinked. Now, back to pure chem, real examples. For example, in electrolysis, this is one of those chapters that if you just study electrolysis alone, you're going to screw up. Why? Because a huge foundation of this chapter is built upon redox reaction. If you do not know what is oxidation and reduction, and you try to do electrolysis because you say like, oh, I need to revise this chapter, you realize you have a very hard time because at the anode, that is an actual oxidation half equation. And at the cathode is a reduction half equation. So if you don't even know your oxidation and reduction well, you can't calculate oxidation state. You're going to struggle with the whole chapter on electrolysis. Another example is mole concept. Mole concept is one of those that students really hate. Why? Because it makes its appearance in many different chapters. For example, it appears in electrolysis. It can also appear in chapters in organic chem. All right, so you need to realize that a mole concept is not a chapter that I can study, but mole concept is more of a blanket chapter which can span across many different chapters. So those are all some of the more nuanced details that you need to know. One of my favorite that I like to say is QA. QA, many students think that, oh, it's just I need to memorize QA and they think it's done. That's completely not true. QA, if taught properly and you know how to study it, is actually very heavily linked to acid, bases, and salts. If you can see that a lot of the tests for anions are actually precipitation reactions, you realize that precipitation came from salts. QA, the test for anions is merely precipitation reaction. Then suddenly a lot of things will make sense. So instead of studying QA alone separately, for my students, I always tell them study acid, bases, salts, and QA together, because that is the 3 dots, right? That's how you link those chapters together. And once you're able to see that, you realize that actually chemistry is, instead of topics, is a cluster of topics. You can put similar topics together and suddenly things would start to make a lot more sense. And a lot of the topics are actually interlinked with one another. For example, I'll give you another example, real example, right? You learn sulfur dioxide, right? Sulfur dioxide is in air and atmosphere, it's a pollutant. But on top of that, you need to realize that SO2 is also a reducing agent, and that is under redox reaction. If you're able to connect the dots that way, then you realize that, hey, suddenly like a lot of things in certain questions will start to make sense and they will surface. And the moment you learn the whole syllabus and you're able to connect all the dots, realize that chemistry is actually very limited in terms of what you need to learn, because everything overlaps. One last example, I feel I'm giving so many. For example, you know reactivity series in metals? You'll need that for electrolysis for ease of discharge. So those are just some simple dots you can link. So there's no point studying like electrolysis if you do not know your metals, if you do not know redox reaction. So I think overall, chemistry with the proper guidance, if you're able to connect the dots between the chapters, that is when you realize that chemistry is actually very easy. So I have some students that started hating chemistry, but the moment they went through the proper guidance, right, they know that, okay, this is how you study. And once they understood concepts, they joined the dots and they mastered their answering technique. Suddenly they're like, why is chem so easy? Then that is the point whereby you know that, oh, they will start to like chem more and, appreciate the subject on a deeper level.
I love this tip because that's what I do a lot for my bio students as well. I always like super eager for my students to finish the syllabus, because I feel like every time I teach one subject, like for example, I teach like nutrition in human, then we will learn about one blood vessel, like one hepatic portal vein. But I always like super eager that, how this is like a puzzle in like it's one piece of puzzle in a very big piece of puzzle, but now you're only looking at this, so it gets very confusing. And it's also very limited as to like how much I can explain about this one piece of puzzle. I need other pieces to show them the complete picture. So I always very excited when I teach some subject, then I can link back. I always like that. If you ask my student, that's what I always do. Every single subject, I will talk about other topics. Every single topic, I'll talk about other topics, like how they link to each other. So I absolutely love this tip. I think even though they may not be something that are like tested explicitly, like, oh, how is this linked to this? I think it helps with the understanding. It helps with like just like a very holistic understanding of the whole subject.
I call this zooming out lah, if you all want to get a bit of perspective, because when you study, you always try to zoom in, you try to go into the details. But when you zoom out a bit and you take a step back, you realize that actually the syllabus is designed in a certain way to convey a certain set of knowledge. And often this knowledge are all interlinked, because that is how science work, right? Science don't work independently. They all affect one another. And I think that is the main takeaway here. So when you're studying, don't be too fixated on a topical basis. For me and my students, right, we rarely do topical, maybe at the start when we are learning. But once we are past a certain phase, it's always thematic revision. You never ever do questions from one topic again, because the topics are all interlinked. I think the moment you get that, then you realize that actually, the main clusters of topics are fixed. Then you're able to link them together, then life gets a lot easier. Okay. Anyway, down to the final, I shared 3 tips. This is just a bonus. If you're in a state where you really want to improve your chemistry quickly and you don't have the time and don't have the resources, but you just want to make a rapid improvement, this is what I suggest. It will probably take you less than 10 hours, at most 12 hours, but you can really see a radical improvement if done correctly. This is what I call the one cheat sheet or whatever. I don't have a name for it, but basically every single chapter you only have one A4 paper to cram whatever you need onto that paper. So how do you cipher out the most important information? You're not going to write everything, but instead you're going to write the most important key concepts, key things to remind yourself. And as you browse through your answering technique, you want to write down certain answering structures that you must have, maybe 1 or 2 per chapter. That way you build, for example, if your mid-year exam has 16 topics, you have exactly 16 pages. So when you look at these pages, you know exactly what to look out for, what kind of question types might come out, and what's a certain answering technique. I think this is important, especially when you're trying to establish your base. Don't try to cram too much information from one chapter and, not seeing the overall balance of things. So what I recommend, if you really want to improve quickly and you're in a state whereby you're struggling for chemistry, the first step is just to make sure that every chapter, there is this one page with whatever
can use the learning outcome as a guide.
Correct. So I think Xin Wei brought out this learning outcome. If you're wondering what exactly that is, you can actually search on it on the internet. You just Google, you type chemistry O level. There will be this thing called your syllabus code, right? So certain numbers, I can't remember the exact numbers, but you can go and find it. Every single chapter, they will list out the specific learning outcomes that you need to have, which means by the end of this chapter, you need to learn the difference between proton, neutron, and electron. So there you can go and look in your textbook. Then you're like, okay, this is the difference between the three. You can draw a table to categorize your information, bullet points, keywords. Then suddenly, if you look through all the bullet points, if they all appear on your paper, that's when you're done with the chapter. You quickly move on. A chapter should not take you more than 45 minutes. Then once you're done with like your 16 to 20 pages, you can look through them. That is your go-to Bible, at least for your mid-year exams or sorts. Then you go and attempt practices. You see if that information can be found in your paper. If not, you might have blank spaces, you can add it on. But that is one of the fastest way, if you're looking for improvement, to consolidate information and key concepts. And that hopefully, can help you out from a place of where you're struggling, slowly to a point where you eventually enjoy the subject. Yes.
Agree.
Okay, anyway, this episode, not much talking from Xin Wei because it was meant for me, right? I really wanted to just share more on the chem side of stuff.
I agree. I think all these are not just for chem. I feel like they are very applicable to other subjects as well, especially at least for bio. Like what I'm hearing is exactly what I would tell my students as well.
Okay, so I hope that with this sharing, hopefully you don't think of chemistry as such an intimidating subject, but more importantly, for you to be able to do well and overall just get better in chemistry. I think if any of the things that I've said today manage to help you even a little bit, that to me means a lot, right? Because now I've made your journey a little easier. So that's pretty much the end of the podcast. So if you enjoyed the podcast and you're watching this on YouTube, please subscribe and give us a like so that the video can reach more people across the platform. And with that, we will see you in the next podcast. Bye, everyone.
It sound right, boy.